Put it on this computer, share the
Timer's still
quizzes.
going.
It shouldn't be going. It stopped on here. I hope it stopped. I don't see a timer on mine. I don't know. On either one. On
Weird,
my
mine is still going. Maybe I need to refresh.
Yeah, maybe refresh it. Okay, so all flamingos have feathers. We want to rewrite this as an if-then statement. So in case you're wondering what we're doing the logic worksheet to wrap up chapter 1. So the logic worksheet is on Blackboard. It's got its own separate little tab. There's something like logic exercises, and you can click on that little worksheet. And so that's what we're going to be filling out to get through chapter 1. So 1A was logical fallacies. 1B, we talked about propositions, so things that are true or false. And then we combined them with what? And statements. We did or statements. Or statements could be exclusive or inclusive. And then we did the conditional if-then statements. So now we're really going to work with those if-then statements quite a bit to sort of demonstrate validity of arguments, right? To determine whether something is valid or not. And so if all flamingos have feathers, and we talked about this, if P then Q, if I'm drawing like a Venn diagram, what does that look like? We talked about like, it'd be like what, P is a subset of Q, something like that. So if all flamingos have feathers, what does that mean? If then, is it to mean if they are a flamingo, they have feathers, or is that saying if they have feathers, it's a flamingo? I think we're 4 people. 4 people. Hopefully they didn't fall asleep during the Abbott and Costello. Oh, it might be me. I might be one of them. Okay, so how many people we got? 26 people on the roster. So there are 3 people that are logged into Zoom that aren't logged into this thing. So hopefully you can find a device to log into the quizzes and play along. So it looks like, whew, that's pretty good. Most of you got it. So all flamingos have feathers. So every single flamingo, so that means if I pick a flamingo here, then it's guaranteed to be also within this set. So there could also be other things that have feathers that aren't flamingos, right? If all flamingos have feathers. So this is mostly like, that is a true statement. So we might get to some statements that aren't true in reality, right? This is a true statement. So if we think about it, that means if it's a flamingo, then it's going to have feathers. Did I do that the right way on this one? Yes, okay. There's one that I messed up on, but I fixed it. So I think it'll be all right. So I'm going to go through this, and then I'm going to show you a little bit how to do it on the worksheet, or how the worksheet is kind of structured, because the worksheet looks a little weird, if I'm being honest. I like the worksheet and everything that it has. Now we want to know what does this say? If flamingos then feathers is what we're saying. All flamingos have feathers is like saying if it's a flamingo, then it has feathers. So what does that Venn diagram look like for if flamingo, then feathers? Oh man, and I really want to encourage y'all to like stay with it today. Like this is a fairly long section. I felt like my other class was just like kind of sleeping. I just finished off my coffee, so I got a lot of energy. All right, so this is looking good. Okay. Yeah, so it definitely is not this one, right? It's not disjoint. So they are subsets. So these are the subsets. So if flamingos then feathers, looks like the flamingos is the subset of the feathered creatures. So we could put an X out here and it would be like a feathered creature that isn't a flamingo. We could put an X in here, it'd be a flamingo, and it would also be a feathered creature. We could put an X outside and it would be neither, right? Ooh. Follows that one. All feathered creatures are flamingos. Shuvah. All right, so this one is backwards, right? So all feathered creatures are flamingos. So this, I think, is a little bit like not as good as the previous one. And like, I think if I were to put my money on it, I would put my money on the fact that it is, because it's not true. It's not true in reality, but we're saying it, right? So what we are saying is that all feathered creatures are flamingos. Therefore, if we pick the creature that is feathered, it's going to be guaranteed to be a flamingo. Whew. Which is not true in reality, and neither is this sentence, right? So all feathered creatures are flamingos isn't true, and neither is if it has feathers, then it is a flamingo, right? Those are saying the same thing. Neither one of those is true. This would actually be a true statement, the one on the left, right? I say that word too much. I noticed when I like go back and listen to myself, I say the word right a whole lot. I shouldn't point it out because now you're not going to notice it probably. I've cursed you with hearing it. All right, so what does that Venn diagram look like? And again, this is a really weird statement, but this says, if feathered, then flamingo. What would that Venn diagram look like? Mm-hmm. So there's one person sleeping that didn't log in to quizzes. Two people. One person. All right. Ooh. Okay, it looks like most people are getting it. If feathered, then flamingo, which means feathered is the smaller set, flamingo is the larger set. So this is like the other statement, just kind of backwards from what they were saying. I think the next one says the assignment. So I want to stop this right quick, and I want to flip on over to Is that better? That's better. So how to fill this thing out. So this is a little bit weird, but
and this box isn't right.
This is part A. So if it is a flamingo, then it has feathers. And I'm going to abbreviate a little bit. It's probably right out the whole word, but So this is what we just answered. So somehow, either if you can print out this worksheet and put it on there, that would probably be preferable from your standpoint, but you don't have to. I know not everyone has a printer, so you can definitely work around it, but somehow you need to give me the if-then statement. You need to give me the Venn diagram for it. And then the next one is giving me the if-then statement. So if it is a feathered creature, then it is a flamingo. So feather, flamingo. Trying to write it. There we go. Any questions about like how to fill this thing out? So this was like the first two questions that we answered, and then you're gonna come back. Sorry, get my computer. But there we go. That is the second two questions that we answered. Okay. Does anybody have any questions about where to find this? I'm hoping like y'all are all finding this on Blackboard under the logic exercises tab. It should be right there. Okay, so if there's no questions about that, I think we're gonna go back to quizzes. And we're gonna continue answering these on the quizzes. So there are basically three different parts to this worksheet. There's like this part, and then there's writing the inverse and contrapositive and converse. And then the last part is the actual analyzing arguments part. That's pretty straightforward. Okay, so which of these, this one is already an if-then statement, so I didn't bother breaking it apart into an if-then statement or doing a question like that. I hope you can do that on your own. So definitely rewrite this. You should have the statement written somewhere if you turn it in, right? Basically, if-then, it's already there. If you have a ticket, then you can see up. So I'm hoping already in your brain, hoping you're like rejecting two of those real quick. Because we see it's an if-then statement. We know if-then statements look like subsets. Oh man, did they fall asleep when I went to the worksheet? Come on. Oh, it's pretty explanatory, I feel. Where are we at? One more person? All right, come on, we gotta get going. All right, good. All right, so most people are getting that it is supposed to be between like kind of these two. Ooh, why are so many people looking at this one? So the first thing we see here is ticket. So this is like my P statement. This is my antecedent. This is like my hypothesis. Antecedent, constant, what does it say? Antecedent and consequence. And what? I'm trying to think of the other word they use for it. Okay, so anyway, this should be the subset of this one. So the ticket should be the inside, the seeing the up. And hopefully you notice like this way makes sense. If you see up. If you have a ticket, then you can see up. So now what are we asking? If you have a ticket, if you get into see up, then you had a ticket. So how does that differentiate? Oh man, I'm not leaving the timer on this. I'm going to keep the timer on this one. Y'all should be able to get this one quick after that previous one. Like if you had a ticket, then you see up as 1. If you see up, then you had a ticket would be the other way around. And so the one that is the other way around, are we getting it? Hopefully we got it. Oh, okay. I think most people, oh, there's a few people still selecting the other one. This is the other one, right? If you had a ticket, then you see up. If you see up, then you had a ticket. So those are two different things, right? This is saying if I purchase a ticket, then I'm guaranteed to get in. This is saying if I got in, then we can guarantee you had a ticket. That's not necessarily the same thing. That could be someone that snuck in here, right? Okay. Oh, I hate these ones. So it is necessary and it is sufficient. So I would give you a little heads up. This is backwards from what it sounds like, at least to me personally. So it says it is necessary for the number 10 to strike out in order for the Mud Hens to win the games. So if you want a little tip, I'll keep going. If I read this, it almost sounds like it should be if number 10, then Mud Hens. But it is necessary flips that. So if that helps. That is not what it is. Where are we at? 5 people. This one's hard. Like this is one I gotta like stop and think about. It is not like an obvious sort of phrasing and why it is. It is necessary for things to be odd that are prime in order for them to be prime. Therefore, if you pick something that is prime, you can guarantee that it is odd. So it is backwards from what it sounds. So it should be if hens, then number 10. So I gave you a little bit of a hint. It is weird. This is a weird phrasing. The necessary one is weird. The sufficient one, I will give you a hint, is straightforward. It is like it sounds. And I think that's the next one. So I think we would do the Venn diagram for that. No, we got to do the Venn diagram now. That's what we're doing. So it is necessary for number 10 to strike out in order for the Mud Hens to win the game. Again, this one was if Mud Hens, then number 10. So we want to draw that Venn diagram for if the Mud Hens, then the number 10. I feel like I give y'all like a few more minutes, a few more seconds, I mean. Come on. I feel like I'm like speaking caveman English or something up here. Oh. All right. There we go. Okay, so if Mud Hens win the game, then number 10 struck out. So that would be the Mud Hens on the inside, the number 10 on the outside. So if there's one thing that you're going to get down, one thing that you really should get down, it's this thing right here. The if-then statement and how to draw it as a Venn diagram. This is going to come up, and it's going to come up like again and again when we start like analyzing arguments. So if P, then Q means P is in the inside, Q is on the outside larger set. Getting that subset sort of picture in your brain. All right, so it is sufficient for number 10 to strike out for the Mud Hens to win the game. So it is sufficient means if you meet that, then you can kind of guarantee the other one, right? And the way this worksheet's set up, right? It's kind of set up, here's one way, here's one the other. I don't know if y'all noticed that, but that's kind of the way it's set up. All right, we got a lot more slides to go through. Someone falling asleep now? We're still here. Oh, there. All right. All right, it is sufficient for number 10 to strike out for the Mud Hens to win the game. So it is kind of straightforward like it sounds. The other one, you kind of have to flip what it does, right? This one is like, it is sufficient. This is P, this is Q. So if number 10 strikes out, then the Mud Hens are going to win the game. And then I think we're doing what, a Venn diagram for it. So I want to spend too much time. I think we can do it within the time limit, right? So it is sufficient for if number 10, then the Mud Hens is the Venn diagram I'm looking for. So if number 10, then Mud Hens. What is that guy going to look like? I already took out like 2 of the options now, right? I'm just like showing you the subsets. So I'm hoping at this point you realize it's not looking like disjoint or overlap sets. It's looking like subsets. And if I say if number 10, then Mud Hen, then number 10 goes inside, Mud Hen goes on the outside in the larger set. So number 10 is a subset of Mud Hens. I feel like if someone just like walked into this classroom right now and just like didn't read the slides, but just heard the words coming out of my mouth, they would just be like the most lost, right? It's like, what the heck is this guy saying? Don't forget, there is a 1G and 1H there for you to complete. So I did most of all the problems in the first section. There's just like one little box for you to complete on your own. So I want you to complete that on your own. Just make sure you understand the concept that's happening there. Again, if you got questions, I got hours after class, office hours after class. You can always come by. That's the easiest way. You can try to play tag through an email, but doing like work through an email is just like, it's not very practical. It's more practical for you to come into class or to come into office hours. Like, if you have an iguana, then you have a reptile. So what is that Venn diagram going to look like? Yeah. So where are we on this one? Are we understanding this? Seems like more people are getting this concept. So really, if you have questions about this, speak now or forever hold your peace. I don't know what to tell you. Besides, ask some questions if you don't understand where we're getting this picture from, this statement. So iguana is the first thing. It's going to go on the inside. Reptiles is the larger thing. It's going on the outside. And this statement is a true statement. Oh, wait, are we in part 2 now? Okay, so part 2, it has that little box for you to draw a Venn diagram up top. So this one, I don't feel like the structure is too confusing. The next thing we're going to want to do is write the converse. So again, if you have an iguana, then you have a reptile. Converse, inverse, and contrapositive. So we're going to write all 3 of those things eventually. But now we want to write the converse. So what is the converse? Smelly pair of sneakers, something like that. Converse is, I'll give you a hint, it's got the con, it's got the swap. So it's like the statement, but we want to swap things. Oh, it looks like somebody are getting it. What does this look like? So we want to swap those. So if you have an iguana, then you have a reptile is the original statement. So in order to swap those, seems like a lot of y'all are getting it. So if you want to swap it, it's backwards from this, right? If you have a reptile, then you have an iguana. So we're doing the last part first and the first part last. Swapping our consequence and antecedent. So there are a few people. I'm one of them. I know I didn't say nothing. It's about 5 people who hadn't said nothing. So if you're one of those 5 people or 4 who hadn't said anything, if you don't understand this, now's the time to sort of ask. If, well, so I don't know how, let's see if it gives you credit. So 5 people got credit for it. So I don't know, it is really picky. And it looked like most of you were getting things correct, to be honest. So it's probably like some kind of typing sort of thing, really small issue. Positive side is I don't think it gives you points for these. I don't think you're getting anything off if you get those wrong. Does make things a little more fun though. So now we want to write the inverse. So there's the converse, which swaps things. There's the inverse, which inverts things. So if I want to invert like a phrase, if you have an iguana, what do you think I mean by like inverting it? Does that make sense?
Turn it inside out.
Yeah, so if I have an iguana, if I wanted to kind of like invert it, it would be like if I don't have an iguana, right? So if I don't have an iguana, then I invert the other one too. I think some of y'all are getting it. If you don't have an iguana, then you don't have a reptile. I try to put like these things in. See, you capitalized iguana, so it's probably not going to give you credit for it because it's like it's going to be really particular. And I try to put like different variants in there so it counts it right. Actually, these I think it might give you points for because it's short answer. It's the open-ended that doesn't give you credit. It's more for immediate feedback anyway. So I can see what you are doing. We can interact a little bit more. All right, so we talked about this one. I think we talked about it enough, hopefully. I'm going to hit the enderoo there. Okay, skiddly doo doo doo. Oh. Let's see who gets credit. How many? Woo, it's getting better. All right. And then the last one, is a contrapositive. And so what I would kind of take away from this is you have a converse, which you swap them. You have an inverse, which you negate the statements, right? You say the opposite. You invert them or negate them. And then you have this contrapositive. So the contrapositive, I was going to tell you, you want to do both. You want to swap and negate. And so what I would really kind of take away from this is that the original statement, if you have an iguana, then you have a reptile, is going to be the same logically as this statement. If you don't have a reptile, then you do not have an iguana. And so the original statement and this statement are logically equivalent. And then the other two things that are logically equivalent are the converse and the inverse. So they mean, like, logically, they mean the same thing. Sometimes we use this in math because sometimes it's easier to sort of prove the contrapositive than the original statement, depending on what your statement is. So that does come into place somewhat in like higher math when we start proving things. All right, so are there any questions about this guy, about how to swap and negate him? So if you want to type in your solution, I'll give you a few more seconds. See if you can get it exactly like the computer wants to get it if you want. All right, for the most part, I think people who answered are probably going to answer. Okay. So if you do not have a reptile, then you do not have an iguana. Can y'all see this? Does it come up on the phone too? Want to give you that little thing? Nope. It comes up on my screen, huh? It's getting warm in here. That's an appropriate question. If hell freezes over, then I will root for the Aggies. Okay, so this is about getting the if-then statement Venn diagram down. So we gotta get this thing down. All right, so the first thing is hell freezes over. So hell freezes over should be the thing in the smaller circle. Rooting for the Aggies should be the thing in the larger circle. Is it just the timer? Did the timer make y'all freak out? I'm hoping like y'all get these statements down. So we want to write the converse. Or I mean, like, I hope y'all get those Venn diagrams down, is what I meant, not like these things. These things I want you to be familiar with, but it's not, I wouldn't put as much of an emphasis on like these statements as I would like per se, like the if then and doing the Venn diagram off that thing. That's really important. If you're not getting that, you need to ask some sort of questions. So what would the converse of this thing look like? I'll give you a few minutes, a few seconds before I switch over and look at responses. Let's see if I get this right. Let's see how big it is. All right, so what are we saying? The converse is like you're gonna swap those things. So what are we saying? If I root for the Aggies, then hell freezes over. Or hell is frozen over, something along those lines. If I root for the Aggies, then hell will freeze over. That's good. Root for the Aggies, hell freezes. Something along those lines. All right. Miss Schramm was the one that originally made this worksheet, I think. She came up with a lot of these examples. Some of them are pretty goofy. It's pretty great. Okay, so if I root for the Aggies, then hell freezes over. Hell will freeze over. So I think most of you were like in the correct sort of ballpark. It's probably just the computer being silly. And if you're not and you have questions, now's the sort of time to ask them. Why are things the way they are? So write the inverse. So what does the inverse of this thing look like? Bit-a-ba-doo. And so now is a good time to get the practice in because you're going to have to do one of these on your own. Okay. And it's like one of those things whenever I put in the answers for this and try to get it to be correct. Like I have to try to guess every sort of variant that you might answer, right? It's like don't or do not, won't and will not. Gotta try to like figure out every different variant and put it in. All right, so what does the inverse look like? It looks like nope, nope, nuh-uh, nuh-uh. No way, no way. Where's it going? Where's it looking here? Look. I want to look at these responses. If hell doesn't freeze over, then I will not root for the Aggies. That is it. Nope, nope, nope. We say nope and nope, right? If not P, then not Q, basically, is what we're saying. We don't swap the orders or the order stays the same. We just say nope and nope. So if hell does not freeze over, then I will not root for the Aggies. So that's a bunch of nope for me. Any questions about this, about how to write the converse and the inverse? And again, like just as a reminder, the converse and the inverse are logically equivalent. They are saying the same thing. So if I root for the Aggies and hell freezes over is the same thing as saying if hell does not freeze over, then I will not root for the Aggies. Whew. And then the original statement and the contrapositive, which we're about to write next, are logically equivalent. And I think this makes like a little bit of sense, like, or it's like something people would say, right? If hell freezes over, then I root for the Aggies. We know hell's never going to freeze over, right? which means you're never going to root for the Aggies. And so what's the opposite of that? Or there's sort of like the other side to the coin is maybe like the way to describe it, right? If hell freezes over, then I will root for the Aggies. There's a sort of other side to the same coin that's saying the same thing, but in another way, if that makes sense. If I wouldn't. And there's a bit of like we should probably do some shifting of like past tense, present tense, and future tense sort of thing. But I don't really care too much as long as you're getting the sort of structure there. Like it's not, the English isn't like the thing that I'm trying to grade you on here so much. So remember, a converse is like a con. There's a sort of swap. In inverse, we're going to invert or negate statements. Contrapositive, you're going to do both of them at the same time, right? I'm probably going to get it wrong just because the wording on this is kind of weird. So if not this one, then not this one is what I want to do. So let's hopefully we got something along those lines in here. Let's see what people are saying. If you don't root for the Aggies, then hell won't freeze over. Yep. So if don't root for the Aggies, then hell did not freeze over. Yep. 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 So if we think about this, right? If hell freezes over, then I'll root for the Aggies. This is never going to happen. Therefore, you're not going to root for the Aggies, basically, right? Is what they're saying. The other side of that is if you didn't root for the Aggies, we could also guarantee that it was the case that hell did not freeze over. Because if it freezes over and you don't root for the Aggies, right, then you're a liar. Okay, so questions about this? I think that's the last one I have on the quizzes. So there is another one on your worksheet, 2C or not to see. You should definitely do 2C. So if x is an integer, then square root of 13 is an integer. Is what 2C is saying. So we got another problem on there. I want you to try that one on your own. Excuse me. So draw a Venn diagram, do the converse, inverse, and contrapositive. Try to get that structure down. So I'm giving you a little bit to do on your own on this one. What is today? Wednesday? Thursday, Friday. And I'm being honest, like y'all can have probably like a bit more time on this assignment if y'all wanted. It's a pretty long assignment. So this would be typically due what? Like Thursday, Friday. If I'm being honest, I'll probably grade this next week sometime. So as long as you got it in like before like next week sometime, that would probably be all right. Like before Monday. All pigeons are messy. Rewrite as an if P then Q statement. So we had something pretty similar to this, and all something is something. And if you write an if then statement, that kind of like it picks out your P's and your Q's for you. So I went ahead and wrote that down. So we are getting into part 3 of this guy. It is the final part. We are in the final part. We are analyzing arguments now. So this has quite a bit to fill out in each one of these little boxes, but we will break it down and go through it. And I'll show you how to fill this thing out. So all pigeons are messy. Rewrite as an if P then Q. I'm on fire. That's what it says. Should I stop, drop, and roll? Okay, where y'all at? There's 4 people. So all pigeons are messy. We want to write that as an if-then statement. How does that look? And then after you write it as an if-then statement, the P and the Q kind of pick themselves, right? So I also got your P's and your Q's up there for you. Okay, we got 2 people. I think I'm gonna go on. This is gonna take the most probably time out of everything here, so we gotta get through this thing. All right, what are we saying here? If it is a pigeon, then it is messy. So we had this before with what? All flamingos have feathers. All pigeons are messy. So if it is a pigeon, then it is messy is what this statement translates to in the if-then terms. And if we say that, then P would be the first thing, which means it is a pigeon. Q would be the second thing here, which would say it is messy. Okay. All pigeons are messy. We want to draw that Venn diagram. So if pigeon, then messy is the Venn diagram we want to draw. And I should have just left that timer there. These are the things like you should, I really hope you're getting this down. People starting to fall off, I think, a little bit. It's a long class. Not as long as the last time I taught this, though. It's a little bit shorter. But we're only going through 1 lesson. They went through 2, so. All right, so I'm going to hit it. Do we even have that many people left? We still got 26 people here. Who's chatting? Who's chatting? Do you do Venn diagrams for all 3 of those? I'm assuming you're talking about part 2 and rewriting those statements. No, you don't have to do Venn diagrams for those 3 statements. If that's what you're asking. Some participants are here too. Okay, yeah, okay. It is this first one over here. Oh man, if you're not getting this, like ask some questions about these Venn diagrams. If pigeon, then messy. Pigeon goes on the inside, messy goes on the outside. So this is the first premise. So if you look at these little boxes that are on the exercise, each little box is an argument. So I believe there's like 9 arguments or something, I believe, or something. But also feel like this is kind of the pinnacle of what we've been working up to, right? So I feel like a little bit of practice is a little bit justified. Perez 2 is Tweety Pie is a pigeon. And I spelled this out for you. on this one. I don't know if I do it on the future slides. But the P is it is a pigeon. The Q is it is messy. So we have to look at this when it says Tweety Pie is a pigeon. The first thing I hope you ask yourself is like, is that a P or Q? Am I talking about it being a pigeon or am I talking about it being messy? And then the first thing, am I confirming or denying it, right? So if I'm confirming that it is a pigeon, I'm saying it is a pigeon. If I'm denying that it is a pigeon, I'm saying it is not a pigeon. So if I'm confirming it, it's true. If I'm denying it, it's making it false, right? Okay. I think 2 people fell asleep. I hope it's not 3 people now. All right, so I think 2 people fell asleep. I don't want to spend a whole class waiting on someone that's not going to answer. You know, it's hard to make the judgment call. If I'm going too fast and you're one of those 2 people that I'm like passing up, let me know. But it looks like most of you are answering things correctly. It is definitely a P statement. This says Tweety Pie is a pigeon. It is something saying that about them being a pigeon. It is not saying anything about being messy. So it is definitely a P. If it is confirming that Tweety Pie is a pigeon, then P is true. So if it said Tweety Pie is not a pigeon, then that would be saying P is false. And then we're looking at this premise. We want to put an X in our Venn diagram to represent Tweety Pie being a pigeon. So the X represents Tweety Pie. And we want to put the X such that it represents him being a, stop that timer just for a second, represents him being a pigeon. So which one of these Venn diagrams is correct? And this was the Venn diagram that we drew previously, right? Now we're just putting an X in it. It's the same one. We want to represent premise 2. All right, I think that's probably going to be the people we get to answer. Oh, look at that. Good job. And so we want to represent Tweety Pie as a pigeon. I like that someone answered this one. Because this one, it looks like it almost guarantees that Tweety Pie is a pigeon, right? But it could also be on the outside. So if you put it on the border of a circle, that literally means we don't know if it goes in the circle or outside the circle. It could be either way. So this picture right here could possibly be this picture over here, right? Is what we're saying. Like this X could potentially be either this one or this one, is what that thing in the middle means. It means we don't know. And therefore, Tweety Pie is messy. So now we want to know, is this a P or Q statement? I believe is what we're now asking. I believe, yes. And if we remember correctly, P was the pigeon statement, Q was the messy statement. So P was, it is a pigeon, Q was, it is messy. So what is this doing? Is this a P or Q statement? Is it confirming or is it denying? Oh, excuse me. The P or Q statement. Come on, there's 2 more folks that are probably going to answer. You got a 25% chance of getting it right if you just randomly guess. You got a 50% chance right if you can distinguish the words what? Pigeon from messy. You got a 50% chance of getting it right if you can distinguish the word is from is not. All right, there's one more person. Come on. Oh, don't tell me we lost another person. All right, who's organizing the search party? I got any volunteers? Is it going to be a volunteer search party, or are we going to have to actually pay people for their labor on this one? All right, so let's see where we are. 21 people answered it correctly. It is definitely a Q statement. The messy part was the Q statement. It is confirming it, so it is saying Q is true. And we want to look at this. We have our Venn diagram. And now is like kind of the big important sort of question, I feel like. It's like the overall, is this thing valid or invalid? Can we draw this conclusion based off of that picture? So if I put an X inside that circle that says pigeon, what can I say about the quality of that thing being messy? And then after this, I think I'm going to show you what the structure of the worksheet looks like. The structure of this on the worksheet, I think, is just like part of the problem is it like confuses people. And so I understand like if you don't have a printer and if you're writing this thing out, that's cool. Like that's fine, right? That's perfectly fine. Just make sure you like contain all the information that we're going through. I think we lost 3 people now. And so I just think I just need to put it on there. All right, so this is valid. And like going through this, says Tweety Pie is messy, is the conclusion that I'm drawing. So this is the picture. So if I look at this picture, and the first thing that they said is if it is a pigeon, then it is messy. That gives us the sets, right? That gives us the Venn diagrams. That tells us the picture of the Venn diagrams. The second premise is Tweety Pie is a pigeon. So that's where we put our X in the circle that Tweety Pie is a pigeon. And then the conclusion they're trying to draw is Tweety Pie is messy. And so if we put an X in this pigeon circle, what can I say about its relationship to this messy circle? Well, if it's in this one, guess what? Like it has to be in this one. Is there any way that you're going to put it in this circle and it's not going to be in this circle? If you can, I will pay you money for that. If you can draw a Venn diagram with the rules of Venn diagrams and do that. Let me be more specific. It doesn't happen, right? This is a subset of this. If I put an X anywhere in this circle, it will be contained in this. And so this is really relying off of like what if-then statements. If I flick the switch, then the light comes on. That's one way to turn the light on. There could be other ways to turn the light on, maybe. It's getting into the property of subsets too, right? The if-then statement is also sort of similar to that property of subsets. If I put it in the first one, if the first antecedent is met, I can sort of guarantee the consequence also has to follow, right? Okay, so now, so like if I flick the switch, I can kind of guarantee like the light will come on, right? So if you flick the switch, then the light comes on would be the first thing I put forward. And then the next thing would be I flick the switch would be my second premise. Then the conclusion you could draw is that the light comes on. So this is if you're pigeon, if it is pigeon. then it messy. So a little bit about the way that this is set up. We just went through this on the little quizzes, so I'll probably go through it kind of quick. But this one says, what if it is pigeon, then it is messy. So the first P is, it is a pigeon, it is messy is going to be the second part. And then this one, I think this is the thing that really messes people up, because they try to like, they try to put a check mark next to each one of these or something. I don't know what they're doing. There should just be one check mark on this. And this is this statement, Tweety Pie is a pigeon, was saying that P is true. The conclusion, wait. I should really start drawing my Venn diagram here. So for this part, all pigeons are messy. I think I skipped over that part, huh? If I want to draw a Venn diagram for all pigeons are messy, it looks like pigeons on the inside, messy on the outside. That's this statement. This statement, Tweety Pie is a pigeon, says I put my X in this pigeon circle. And then now I'm looking at my conclusion, seeing what my conclusion says. My conclusion says Tweety Pie is messy, which is a messy statement, which is telling me that Q is true. And the argument we have already discussed is valid, right? If I put it in here, it's guaranteed it also has to be within here. So this is asserting or assuming the hypothesis, I think is one of the ones, right? Hypothesis, consequent, antecedent. You ever hear like people say antecedent cause? That might be a good way to like kind of remember that, right? The underlying antecedent causes to something. This is causing this to happen. The property of this thing being a pigeon is the thing that causes it to be messy, so to speak. Okay, so, oh, never mind, right now. Back to the quizzes. Are there any questions about filling out this worksheet? So I know if you can print out the worksheet, then that's good. If not, then somehow convey everything that's on this worksheet. I want the if-then statement. I want the P's and the Q's. I want to know what that statement says. You should basically be answering the same thing, right? You should have a Venn diagram. It should have subsets. It should have an X in there somewhere. Tell me what this says. Okay, my iPhone's in here now. All right, so now where are we? We are here. And the next one, the second argument says, all integers are real numbers. So we want to convert this to a if-then statement. And we've had this sort of structure before, like twice. I think this is the third time we're seeing the same sort of phrasing, right? So if what, then what? All integers are real numbers means if, and if you can do that, then you've got your P and your Q set up. There's about 2 or 3 people. Oh, come on, this is a 50-50 shot. I think there's 3 people that fell asleep, huh? All right, so it is definitely the first one. If integers, then real numbers, which means P means the number is an integer, Q means the number is a real number. And then now, what are we gonna answer? P and Q, and now we're looking at the Venn diagram for that first premise. So if it is an integer, then it is a real number. And this is a true statement. So like your Venn diagram should also be something that is sort of true in reality. We've had this picture drawn before when we did 1C. So I think I might leave the timer on. It's a little quick on this one. But we need to start getting through these a little quicker, I think. So let's see. Did we get the right one? Looks like most people are getting it. If integer, then real number. The integer is the subset of the real numbers. And so now we're looking at the next premise. So now the next premise this thing is telling me, the next premise they give me is minus 42 is an integer. So again, if it is an integer, then it is a real number. P was the integer statement, Q was the real number statement. So P is integers, Q is real numbers. So remembering your P's and Q's really helps you out when you start answering things about P's and Q's. I just flash in my apartment, probably. If you're gonna edit it online, I would rather you write stuff out by hand than like you have type stuff out. It's gonna be really hard to type certain stuff out in this class. And I like to see that you did the work on your own. And it's like things start getting sketch when stuff is like just typed out. It's like you can share that a little bit easier. Yeah, if you don't have a printer, that's fine. Just make sure you answer everything that it asks. So put down the if then statement, put down your P's and Q's. Tell me what the second premise is saying. Is it saying P is true, Q is true? And like you don't have to write out like everything that's in that box. You just have to write out the responses basically, right? You don't have to write out P is Q, P is false, Q is true, Q is false. So you can just tell me the one that it is. You don't have to write out every single response and then put a check mark. Like it doesn't have to be like stupid pristine, but it does have to convey the responses I'm looking for, right? You got to put in what the second premise is, right? You got to put in what the Venn diagram looks like after that you read that second premise. Because the first premise gives you these sets. That second premise should give you the existence of a member, right? So minus 42 is an integer. So that is telling us something about the existence. So that's telling us where to put that X. We got to put that X. In this one, I'll say it in a second. Where am I at? One more person. Are you going to answer? All right, we're right there on time, so I want to hit this and get through this one. So I know it's like right there on time, right at 4:20. And so if you have to go somewhere, you can go ahead and go somewhere. But I'm going to finish off these slides. I'm going to finish answering these last few arguments. And recording will be up as always. So if you want to go back over the recording and see what we're saying about these, that's fine. But I'm going to go ahead and go through them. try to get a little bit quicker as we go through them, because there is a bit of a redundancy. Therefore, minus 42 is a real number. So again, P was an integer statement. Q was a real number statement. So what is this saying? P or Q? And is it saying, is it true or false? So if P is integers, Q is real numbers. I think I'm just going to leave up the timer on these. It seems pretty reasonable time. What are we getting? Seems like most people are getting it within the time. Therefore, minus 42 is a real number. All right. That is definitely a Q statement because it's talking about real numbers. It's confirming it's a real number. So this is saying Q is true. So I believe we had the picture. We have our Venn diagram. We have our conclusion. Is it a valid conclusion to draw is the next question. And I hope this looks very familiar or somewhat familiar. Can we conclude that that X, which represents the number 42, can we conclude that that has to be a real number based on that Venn diagram? And so long story short, when it comes up, where is it at? We should absolutely be able to conclude that, right? It's like if we put that X in the subset, it's guaranteed it is also going to be within the larger set. Woo, that jumped quick. Sorry, it should have said valid. And I said that should look familiar because it's the same structure as the first one, right? We confirmed the hypothesis. And now we're looking at this one. So this one, okay, the first premise, if we look at the next argument, the first premise is the same. So it says all integers are real numbers. So I don't want to waste a bunch of time writing this thing over and over again and ask the same question. So the Venn diagram looks the same. All integers are real numbers. There's a Venn diagram for it. If it is an integer, then it is a real number. Now we're looking at premise 2. So P is still the integer statement. Q is still the real number statement. Premise 2 is saying root 5 is not an integer. So what is that saying? So P is an integer statement. Q is a real number statement. If it says root 5 is not an integer. Is not. So this, I think, is the first false statement we had, right? Sorry. I hope you said it was false. All right. He's about to hit it. Okay. So what is this saying? I believe it says P is false. Is what I'm saying? It's not an integer. It would be P is false. All right. Any questions about this? I see some chats. Where can we find the recording on Blackboard? It should be on class recaps. It will take you to the YouTube pages that they are located at. The homework that is due is the logic worksheet. So I'm doing most of the logic worksheet. There's like one or two problems from each little section that you might have to follow up and finish up on your own. For the most part, I'm going to finish up most of the worksheet.
Like usual?
Do what now? I said I'd give y'all more time on this one. If you want to spend more time on this one, that's fine. I know the due date is going to say tomorrow at midnight, but if you turn it in late, like, it's fine.
Oh, okay.
As long as y'all get it in like sometime before next week, I think is what I said.
Okay.
Just try to get it turned in like before Monday, preferably. Because I still got stuff to grade for y'all yet too. Ow. Okay. Root 5 is not an integer. So if I want to draw that Venn diagram, spend a second to think about this one. I'll give you a hint on that one. A lot of people, I think, there are like 2 pictures right away, which I hope you're kind of rejecting. And then you look at 3 pictures, and what do we know about it relative to that other thing that we see there? So this one might take you a little bit longer to think about. Okay, so where are you drawing that and relative to the real numbers? All right, come on, we got to get going on this. Should hopefully, I hope like right away you kind of narrow it down to like 3 of those pictures. And so what 3 pictures I'm talking about? Come on. Are like these 3 pictures, right? Is that even visible on this? It's not visible on this, it's visible on your Zoom, huh? These first 2, right, are definitely potentially, this one is definitely in the integer circle, this one is not in there. So nobody answered those. So I think it's between more like these 3. So do we know if it's a real number? Do the premises tell us anything about root 5 and its relationship to being a real number? Just the premises? Like if you're saying yes or no, you're drawing in stuff that you know about math that you learned before, right? You're not drawing from just these premises. So I know you probably know in reality root 5 is not an integer. It is a real number. But based off the information we have, all we know it's not an integer. We have to draw it outside the integer circle, but we don't know if it goes in the real number circle or not. So we draw it on the border. So it could be this one. It could be this one. We don't know. It could be either one of these things, right? So we have to draw it on the border because it could potentially be either this one or this one. Questions about that and why we're drawing it on the border? And if we're drawing it on the border, then our conclusion says, therefore, root 5 is not a real number. So the real number was I'll give you a hint, it was the Q statement. And so if we say root 5 is not a real number, is that confirming or denying the Q? All right, so that is definitely denying. Where's it? Is it coming up? Oh, I went too quick. Sorry, I hit the button too quick. Does it show me my? Ah, dang it. Sorry. Well, I'm going to hit this one. Does it show me the results if I go back? There we go. Okay, so therefore, root 5 is not a real number. This would be saying Q is false. And then we want to know whether it is valid or not valid. Sorry about that. Getting too antsy with the buttons. So can we conclude that root 5 is not a real number? And I'm hoping that Venn diagram gives you a hint as to what we should be saying. Can we conclude based on that Venn diagram that root 5 is not a real number? Let's see what y'all are saying. Survey says. It is not valid. So this X could absolutely go inside the real number circle, or it could go outside the real number circle. We don't know. So we cannot conclude that root 5 is not a real number. And if we look at everything so far, everything was a true statement until our conclusion, right? We started with true premises. If it's an integer, then it's a real number. Root 5 is not an integer, but it is still a real number. So our conclusion doesn't even make sense based on our premises being true. If you start with true premises and you do valid deduction, your conclusion should also be true, right? It should follow. So this is a false statement. So it doesn't even follow from our premises. And in general, I'll give you a little bit of a hint, but if we are putting an X on a border of a circle, it's probably not a good sign that we're going to be making a valid inference. So all integers are, so we have the same first premise. Premise 2 says 7i is not a real number. So the first part is the same. The first premise is going to repeat over and over. There's like 4 examples or so that all have the same first premise, and the second premise basically changes. So I think, where are we at? There's about 17 or 18 people answering now, I think. It's like one of those things, like you can, I know I'm asking a little bit extra today, but you can stick around and get your homework done or try to do it on your own. To me, I would just like kind of get through it. Q is false is what this is saying. So this, my P was the integer statement. My Q is the real numbers. That's not changing from the previous ones. So my P is still my integer statement. My Q is the real numbers. It is not a real number. It's saying Q is false. Okay, so if I look at this as a Venn diagram, what does the Venn diagram for this thing look like? Now I know my Venn diagram looks like the subsets. Now I'm putting the X in there to represent that 7i is not a real number. All right. All right, so we're saying 7i is not a real number. What is that picture going to look like? We have to put it, okay, so most people are getting this. We have to put it outside of the real numbers. And so if we're putting that X outside the real numbers, are there any sort of conclusions we can draw? What are they concluding? 7i is not an integer. So again, P was the integer statement, Q was the real number statement. So if we say it is not an integer, keyword being not, and then that integer represents what? It's a P statement. The not represents that it is false. So it should be P is false, I believe is what it should be. What does it say? Come on up. P is false. That is what it says. And what does the next part say? We're looking at the conclusion now. We want to know whether this is a valid conclusion or not. So if that is where we're putting our X, can we conclude that 7i is not an integer based off of where that X is? Is that X ever going to be in that integer circle? Is what we're asking. Can we guarantee it will not be in there? And so if we put it on the outside, what are y'all saying? Are we getting this? valid, right? This would be valid. So if we put it on the outside of real numbers, it also has to be on the outside of integers. And this makes sense. All our premises make sense. Our conclusion makes sense. If it is an integer, then it is a real number. 7i is not a real number. Guess what? 7i is also not an integer. So this is a valid conclusion. And if you think about the contrapositive, if not Q, then not P, that's kind of like what we're doing here. We're saying it is not part of Q. It is not going to be part of the P if P is a subset of Q. So one way you can think about it is like the original way, right? If I flick the switch, then the light comes on. I flick the switch, you can guarantee the light is going to come on. The other way around is if if the light didn't come on, then you can guarantee I didn't flick the switch. Those are the two valid sort of arguments we can really make. Anything else is going to be invalid. It's probably going to involve putting an X on a circle and not inside, like on the border. And so if we look at this, the first premise is the same. We say 3.752 is not an integer. What is that telling me? So this integers is a P statement. If it is saying it is not an integer, the keyword being there not would indicate that it is false. So I think most of us are getting that it is a P statement. There's this keyword there. When they say not, they are saying that that thing is false, right? So if it is not an integer, what does that look like as far as drawing it on a graph on a Venn diagram? So again, you might notice there are sort of maybe a few different ways you can draw this thing that look like they could be correct. But there's really only one way you should be drawing it. So if it's not in the integer circle, where are we going to draw it? And this should look maybe similar to something we did before. I think we might have had one similar to this. Where are we drawing that X? We have to draw it on the border. So these I feel like you're in the ballpark. If you're hitting over here, you drew it right in the integer circle and it says it's not an integer. So this is like the exact opposite of what this thing is saying. We want to draw outside. This could still potentially be inside the integer circle. These I feel like are in the right ballpark, but we don't know whether it is this one or this one. So we draw it right on the border. Therefore, 3.752 is not a real number. So again, P was about integers, Q was about real numbers. Keywords being what? Not. And then real numbers, which was what? Q statement. So what are they saying? We are saying Q is false. And the conclusion, is that a valid conclusion or not? And I kind of gave you a hint. But there should also be that Venn diagram with the X on the border of the circle, right? Is what our Venn diagram look like. Our X is on the border of the real number circle. And so if it's on the border, can we conclude that it is inside the set? Well, the whole point of putting it on the border was that we couldn't conclude it was in the set, right? So this is not a valid. This should be an invalid way of reasoning. All right, so a few more if-thens. So all accordion players belong in jail. So that is an if-then statement. We've had this structure before. So hopefully this looks familiar. And so that should have said if they are an accordion player, then they belong in jail. And so now we want the Venn diagram that represents that. All right, so it looks like, ooh, 5 of y'all still aren't. I got to get that in the right direction. So the first thing I said was accordion player. That should be the smaller set. Willie does not play accordion. So P was the accordion statement. Q was the gel statement. So if he does not play accordion, keywords there being what not, and then the accordion was the P statement. So what is that saying? Okay, so that's definitely saying P is false. The P is the accordion statement. The not is the false part. Willie does not play accordion. So what can we say? We're looking at this set and think about this one for a few seconds. What can we say about where that X goes? Let's see. I'm hoping this one's getting better. I bet you this one's getting better. It'll look better than those last few, hopefully. This is, I think, the third time we've had something that looks like this. So hopefully, yeah, there we go. It is looking better, I think. We don't know whether it goes here or here, so it's got to go in here. We don't know whether he belongs in jail or not. So he just doesn't, sounds like a cop-out. He just doesn't play accordion. So this is something you can think about. It's a little bit silly, but like they passed a law that if you play accordion, then you're going to get thrown in jail. So Willie doesn't play accordion. And P being the accordion, Q being the gel statement. So if this is a gel statement, I believe it's a Q statement. So what are we saying if we put that word not in there? I believe what we're saying is that Q is going to be false if we're going to say not. So if we say Q is false, yeah, so the not word, I think some of us are still missing that not word, but you're getting the Q part. So there we go. And this is something you could probably think about, like if they made a law that said if you play accordion, then you're gonna get thrown in jail. Willie doesn't own an accordion. Does that mean he doesn't belong in jail? It's like you just see Willie over there murdering someone. He's like, no, I don't have an accordion. Don't belong in jail. Yeah. And I gave you a little bit of hint, like right when we put this on the border. Usually we're going to make something about the one that we put on the border of, right? And what we're saying is, oh, it goes inside of there or doesn't go inside of there. We can't conclude one way or the other. This is not going to be a valid inference. So a lot of that has to do with the fact that it's on the border, right? I think in general, if we don't know and we're putting it on the border, usually we're not going to be able to conclude things in this class. There might be a counterexample somewhere out there. It is necessary for a man to play the bagpipes in order to wear a kilt. So a bit of a word of advice is this is backwards from what you usually think, right? So it is sufficient is the one that goes forward. This one is the one that goes backwards. So if that, then that. Okay. So I have to take a second to think about this. So there's one more person out there, I think, that was answering. Okay. So I'm giving you a hint. It's a little bit backwards. So it sounds like it should be if bagpipes then kilt, but it's not that way. It's the other way. It's the if kilt then bagpipes arrangement. So now P is our, yes, this one, I hate the wording, man. I like it, like, you should be aware of the wording, and you should be aware of this wording. The necessary is backwards. I'll use it in the notes and in the homework, but probably not going to use it too much personally, if I'm being honest. So if kilt, then bagpipes is the one that we want to go with. Okay, we're at next one. Ferguson cannot play the bagpipes. So if kilt, then bagpipes. I believe this is a Q statement. If that helps. So if he cannot play the bagpipes, what are we saying? All right, so we're saying Q is false. What is a Q statement? And cannot means he is not. Come on, arrow. All right, we're almost, I think this is the last example on this one. I think there's 2 more examples after this that I'm going to ask you to do on your own. Cannot play bagpipes. So where are we putting that? What does that Venn diagram look like? So if Ferguson cannot play bagpipes, that means I am going to place my X on the outside of the bagpipe circle. So there is only one picture there that has it on the outside of the bagpipe circle. And that is that last one. This one's on the border, so this one could technically be inside. And so we're going to conclude he does not wear a kilt. So what was it? I believe that was a P statement. The kilt was the P statement. Am I remembering that correct? P was kilt and Q was bagpipes, right? I hope I got that the right way in my brain. So I believe what this is saying would be then that P is false since he does not wear the kilt. And this is the conclusion that we're drawing. So then we want to think about that picture that we drew. If we draw it on the outside of the bagpipes, our picture looks like if kilt then bagpipes, and we're drawing it on the outside of the bagpipes. What can we say about the kilt circle? And this one should look familiar, but it's been a minute since we answered the other one, so maybe it doesn't look too familiar. But if it's on the outside of the big set, what can we say about the small set on the inside? Well, it's also not going to be within that kilt circle. So we can conclude that it's not going to be within the kilt circle based on how we do that. So therefore, that is a valid conclusion. Is that what we are saying? Okay. See, these are getting better. That was the last slide. I'm sorry I kept you all so long. I hope you enjoyed it. If you got any questions, I will be here. I will stick around for office hours. If you got to get someplace, that's it. That's all I got. That's plenty for today. Okay. Y'all are meeting Mondays, Wednesdays? Is that what it is? Yeah. Just try to finish this up. Like I would go and like try to finish it up now personally if I were you. Just get out of the way. You got it on your brain. I'm still recording.